Hello students, welcome to Learner's Planet. Today we'll be starting with the topic coal and petroleum. See, these are what? These are fossil fuels. We'll be discussing about the fossil fuels in this chapter. The fossil fuels like coal, petroleum, natural gas, and these are obtained from nature. So they are also referred as natural resources. We'll be discussing about the different types of natural resources, also the formation of coal and petroleum. So let's start our discussion here. Fossil fuels. What are they? Fossil fuels like coal, petroleum and natural gases are formed from the buried remains of plants and animals over a period of millions of years. Fossil is formed of living organisms. So these fuels are formed from the buried remains of plants and animals over millions of years. These fossil fuels are obtained from nature, so they are referred to as natural resources. See, this picture is showing the formation of coal. The plants, they are buried inside. There is activity by different organisms, and in the presence of oxygen, the compounds present in the plants, they get oxidized. In the absence of oxygen, their reduction takes place. And so this, by the buried plants, what are formed is coal. Likewise, petroleum is formed. Petroleum is formed from the buried remains of the marine animals. So we'll be discussing about the formation of this coal and petroleum here. Let's first see the natural resources. See, there are two types of natural resources. First is the inexhaustible natural resource, and the second is the exhaustible natural resource. Natural resource means the things which are obtained from nature. Like water. Water is a natural resource. Soil, that is also obtained from nature, in which plants are grown and we get food from them. Air, that is also a natural resource. So it's not that every natural resource is an energy resource. That is, you're burning it and getting energy. Natural resource is a thing which we are getting from nature. Like sunlight is a natural resource. It is a source of energy also. Wind is a natural resource. It's a source of energy also. The inexhaustible natural resources. What are these? As the name suggests, there is a limitless supply of these types of natural resources. Inexhaustible means they can never be exhausted. And there is limitless supply of these types of natural resources. The inexhaustible resources are not exhausted by the use of man. Say for example, sunlight, it can never be exhausted. See, solar energy can be used, but it is never exhausted. Air can never be exhausted. These are the examples of inexhaustible natural resources. Wind energy can be used. Say windmills. What these windmills do? They convert the energy of wind into electricity. So power can be generated by using wind energy also. These energies or these sources of energies or these things are called as inexhaustible natural resources. Exhaustible natural resources. What are these? These natural resources are exhausted by the use of man. That is, one day will come there when there will not be any of these resources. Say for example, petroleum. It is an exhaustible natural resource. A day will come when all the petroleum will be used by mankind. Now this natural resources, exhaustible natural resources include renewable and non-renewable resources. Now let's see what are renewable and non-renewable resources. A renewable resource is a natural resource which can replenish with the passage of time, either through biological reproduction or other naturally recurring processes. Renewable resources are a part of Earth's natural environment and the largest components of its ecosphere, like soil, water, different organisms, they can reproduce. See, there are different nitrogen fixing bacteria which reproduce, and they increase in number and thus aid in fixation of nitrogen, which is used by plants. See, atmospheric nitrogen cannot be used by plants or neither animals. So the atmospheric nitrogen is converted into usable form by plants, and that conversion is done by bacteria, and that can be replenished, or that can increase by reproduction. See, soil. It's soil where we grow the different plants. Plants need nutrients. So soil nutrient, this can be improved, or the soil structure or fertility can be improved by crop rotation. Crop rotation can improve soil structure and fertility by alternating deep-rooted and shallow-rooted plants. So it is alternated. Firstly, the deep-rooted plant is planted, then the shallow-rooted plant, so that the quality of the soil is improved. Water can be considered a renewable material when carefully controlled usage, treatment, and release are followed. It is a renewable material, but it should be used in a controlled manner. It should be treated and released. So when there is a careful use of water, then it can be considered as a renewable material. If not, it would become a non-renewable resource at that location if it is not used carefully. Say, for example, groundwater is usually removed from an aquifer at a rate much greater than its very slow natural recharge. And so groundwater is considered a non-renewable resource, is considered non-renewable. These pumps are used. The electric pumps or electric motors are used to take out groundwater, and which takes out water or which removes water from that particular aquifer at a much greater rate. So at that particular point, that water is considered as a non-renewable resource or non-renewable. Removal of water from the pore spaces may cause permanent compaction that cannot be removed, that cannot be renewed. Say we are using electric pumps to withdraw water. So that water removal is at such a high rate that it cannot be replaced. So it gets dried up. Its water pulls more of the water. Right? Because of, say, there are different forces of attraction present between the water molecules. So what happens if the water is taken out carefully? Then there will be some water and it will attract more of water towards itself, deep inside the ground. But if all of the water is extracted and it is at such a high rate, this area will become dry. And there will be no water to attract more of the water molecules. So water, if it is used carefully, and in a controlled manner, it is a renewable resource. Otherwise, it's a non-renewable resource. Likewise, there is renewable energy. We are talking of energy now. Solar energy. It is a renewable energy. Solar energy is the most abundant and easily available renewable resource. Likewise, wind power. Wind power is what? Wind power is the conversion of wind energy into a useful form of energy. You must have seen windmills, which converts the energy of the wind into the electrical energy. Hydropower is the energy derived from the movement of water in rivers and oceans. Originally used for irrigation and the operation of various mechanical devices. So this is also a renewable energy. Biofuel. What is biofuel? Biofuel is a type of fuel whose energy is derived from biological carbon fixation. So which organisms they do carbon fixation? Plants. Right. Now plants, they use atmospheric carbon dioxide and they convert it to their sugars, that is their carbohydrates. So this biodiesel is what? It is made from vegetable oils and animal fats. Biofuel is a type of fuel whose energy is derived from biological carbon fixation. Mostly plants, they fix atmospheric carbon dioxide by photosynthesis. They change atmospheric carbon dioxide into the carbohydrates by the process called as photosynthesis. So by using vegetable oils and also some of the animal fats, animals eat plants. So by using vegetable oils and animal fats, biodiesel is made. Biodiesel is produced from oils or fats and is the most common biofuel in Europe. This is also a renewable resource. Biogas. Biogas is methane, and it is produced by the process of anaerobic digestion of organic material by anaerobes. What is anaerobe? What is anaerobic digestion? See, microorganisms like bacteria, fungi, they are divided into two types, the aerobes and anaerobes. Aerobes, for these organisms, oxygen is required for their survival, whereas anaerobes, they can obtain energy from carbohydrates without oxygen. They don't need oxygen. So anaerobic digestion of organic material like the vegetable remains, and other organic substances, okay, greens basically. The anaerobic digestion means digestion of these organic material by the anaerobes, that is the organisms which can live without oxygen, produce what? Methane. And this methane gas is used for cooking. This methane gas has got a high calorific value and it is used for cooking. So biogas is also a renewable energy source. Actually. And it is also natural because it is obtained from the organic material. Organic material is obtained from the living organisms, be it a plant or be it an animal. See, till now I have discussed the renewable resources, that is, which can be replenished. Now a non-renewable resource. A non-renewable resource is a natural resource which cannot be reproduced, grown, generated, or used on a scale which can sustain its consumption rate. Once depleted, there will be no more available for future use. So these are the resources which cannot be reproduced, just like organisms, which cannot be generated like hydropower, like energy fuel or biofuel energy. Or it cannot be used on a large scale, say like water. Water is used on a large scale. Once they have depleted, they will not be available for future use. And the non-renewable resources or the non-renewable resources include fossil fuels such as coal, petroleum, natural gas, the nuclear power. Nuclear power is generated from uranium, from plutonium, which are present in the Earth's crust. If they are exhausted, they will not be available anymore. Mineral ores or these metal ores, these are also non-renewable resources. Like bauxite. Bauxite is the ore of aluminium. Iron ore, copper ore, gold. These are all what? These are all naturally occurring substances. Once they are exhausted, they will not be available for future use. So these are non-renewable resources. Let's come to energy resources. There are multiple energy resources. It includes fossil fuels, solar energy, different types of power like nuclear, wind, hydroelectricity. This we have done. The energy from garbage and geothermal is also a good source of energy. Energy from garbage means garbage is what? Garbage is organic material. If this organic material is treated with anaerobic bacteria, that is the organism which can live without oxygen, or which changes carbohydrate or which breaks down carbohydrate in the absence of oxygen, producing methane. And that methane can be used as a source of energy. The methane has got high calorific value. That is, when 1 gram of methane is heated, large amount of energy is released. And geothermal. What is this geothermal energy? What do you mean by this geothermal energy? It is geothermal energy comes from the Earth's crust and originates from the original formation of the planet 20% and from radioactive decay of minerals 80%. See, lots of minerals are there which undergo decay, which break down. Say U-238, it breaks down into U-235 and neutrons and releasing a large amount of energy. Likewise, there are large amount of radioactive substances present in the Earth's crust, which go on disintegrating like this, which break down and thus producing energy. At the time of formation of the planet also some energy was there. The temperature was very high. So there is geothermal energy comes from the Earth's crust and originates from the original formation of the planet. That is, it is 20%, and the radioactive decay of minerals, that is 80%. The available energy from the Earth's crust and the mantle is approximately equal to that of incoming solar energy. Do remember this, the geothermal energy. Geothermal energy is the direct use of geothermal energy for heating applications. See, geothermal energy is used for heating applications. Geothermal energy is used for heating applications. Since ancient times, naturally occurring hot springs have been used for bathing. There are hot springs. In Kullu, there is a hot spring. In Kullu Manali, there is one hot spring which is used for bathing. And there are so many hot springs present. So this geothermal energy is used for heating the water over there. Geothermal electricity is electricity generated from geothermal energy using technologies like superheaters, flash steam power plants, binary cycle power plants. The first geothermal power station was built at Landrello, Italy. Remember this. So this energy is what? This is renewable energy. This is the energy obtained from the Earth's crust. Because radioactive disintegrations are going on and they are taking place, and thus increasing the temperature, or thus releasing the energy. Now let's go to the fossil fuel like coal. We'll first discuss about the coal, about its formation, and also about its use, also about the different types of coal. Coal, what is it? It is a combustible sedimentary rock composed mostly of carbon and hydrocarbons. What do you mean by hydrocarbons? See, plants, they are made up of hydrocarbons, that is, the compounds made up of carbon, hydrogen and oxygen. These are hydrocarbons, basically, or you can see the organic compounds. So coal is what? How is coal formed? Coal is formed by the burning of the plants. So it is composed of carbon and hydrocarbons. It is a non-renewable resource. It is black or brownish black in color. The energy in coal comes from the energy stored by plants that lived hundreds of millions of years ago in swampy forests. Let's see how is coal formed. Then I'll come to the types of coal. See, trees and other plants that grew in swampy areas, they were They died, say, 300 to 400 million years ago. And they got buried inside the soil. Over the time, the remains were covered with the sedimentary rocks. See, these are plants. These plants died some 300 to 400 million years ago. And they got buried. They got buried inside the soil. And with the passage of time, they were covered with a layer of sediments of mud and sand. The sedimentation, deposition and subsidence. This gets deposited over here. Now, as it has got buried, what is the oxygen condition there? Low oxygen condition. The plant which was growing had sufficient of, say, carbon dioxide available, and it made its food, then it died. When it died, it got buried inside the sediments of mud and rocks. Mud and sand, right? And here there is a low oxygen condition. In this low oxygen condition, this buried plant formed what? A dark brown colored substance called as peat. This was acted upon by bacteria and fungi, and is leading to the formation of peat. The next step in the formation is gitta. What is this gitta? This gitta, it is formed by the partial decay of peat. There is a partial decay of peat. It has a black and gel-like consistency. This is gel-like. There is a aerobic digestion. Some small amount of oxygen is present, though the oxygen is less. But still it's present. So I've told you that organisms are of two types, the aerobic and the anaerobic. Aerobic means which use oxygen for breaking down the organic compounds. So aerobic digestion of peat by bacteria forms a humic acid or forms humic acid. By anaerobic digestion of organic compounds, what is formed? It is methane. That is in the absence of oxygen. Whereas here it is forming humic acid. And this humic acid, it is buried. Now this is the first oxygenated column of the peat. Now over the peat there are layers or the sediments of say mud and sand. They get deposited. They keep on getting deposited. As a result of which, what happens? The peat goes on buried deeply. It goes on getting buried. Right? Now at the bottom there is deficiency of oxygen. Okay, now this gitta, it is humic acid and it is in the form of gel, or it has got a gel-like consistency. This slowly drains to the bottom of the column, peat column. And this gitta accumulates as a new material, and the new material is added to the top of the column. Right? So this is formed from peat itself. Then the next step. The next step is the formation of, say, lignite. More and more layers are getting deposited. I have told you they are getting deposited over peat. And this gitta, which is formed by the organic compounds, by the aerobic digestion of the organic compounds, this goes deep inside the column. This goes deep in the column. And due to the lack of oxygen deeply, it is acted upon by the anaerobic organisms. Later on, what happens? See, more and more sediments are deposited. And peat gets compressed between the layers, thus leading to the formation of lignite. Lignite is also a coal. See, this gets compressed between the sediments. Further compression results in the formation of bituminous coal. So this is bituminization. Bituminization occurs, further compression. And even further compression results in the formation of anthracite. Right? So what is happening? First of all, see, the plants are getting buried. Sediment deposition and subsidence, it is leading to the formation of coal. It is getting buried. There is action by anaerobic and aerobic organisms. It gets deposited by the sediments. This is, say, sediment influx. This is basin subsidence, and say the compression leads to the formation of lignite. It gets further compressed to form the bituminous coal. And still further compressed to form the anthracite. And then what happens? The mining takes place. Right? See, this is also the thing. The plants get buried, forming peat. Further sediments are deposited. There is time, the pressure is increased, the heat is there, and it changes to lignite and finally coal. Okay? See, this is a textual form. Trees and other plants that grew in swampy areas some 300 to 400 million years ago died, and their remains got buried in the swampy soil. Over time, these remains were covered with the layers of sediment such as mud and sand. In low oxygen conditions, the buried plant material formed a dark brown colored material called peat. See, this is formed by the action of the organisms only, action of the bacteria only, and many other organisms, the microorganisms. Gradually, more and more sediments got deposited over peat. Peat was compressed between the layers of sediments and formed lignite. Further compression resulted in the formation of bituminous coal. Even further compression resulted in the formation of anthracite. Right? Coal is processed further to obtain useful materials such as coke, coal tar, coal gas. We'll be discussing about the processing of coal later. Let's first discuss about the types of coal. That is, the lignite is here, bituminous coal is here, anthracite is here. Now, how this categorization is taking place? Depending on its carbon content, it is divided into. See, different types of coals are there, but depending on the carbon content. See, the more is the carbon. Let's see what is it first. I'll not go deep into it. Lignite. This is a brownish black coal with high moisture and ash content, which has low heating value of all the four types of coal. It is considered as an immature coal that is still soft, and it is used for generating electricity. Right? The more is the carbon content, the more is the calorific value of coal, the better is the coal. Obviously, so lignite is the first thing which is formed after the burying of the plants. Once the plants are buried, covered by the sediments, the first thing which is formed is peat. And after that, after the formation of the sediments over it, the first form of coal is lignite. Now in this lignite, there is a high moisture and ash content, and carbon content is less. And this is also called as immature coal, which is still soft, just that is not hardened up. The second type is subbituminous coal. This is a dull black coal with higher heating value than lignite. That is, its calorific value is higher than lignite and is used principally for electricity and space heating. See, lignite is also used for generating electricity, and bituminous coal, subbituminous coal, is also used for the same. Bituminous coal. It has a carbon content of around 60 to 80%. See, the carbon content is higher than the lignite and is mainly used for power generation and for manufacturing another fuel called coke. It is the most commonly used type of coal for electric power generation. See, lignite is also used for electricity generation. Subbituminous is also used for electricity generation, but the major proportion, the main coal which is used for the generation of electric power is bituminous coal. It is dark, hard coal that has higher heating value. That is, that has got higher calorific value. than lignite and subbituminous coal, but a lower heating value than anthracite. What is first formed is lignite, then next is bituminous coal. So the heating value of bituminous coal is less than anthracite. Anthracite, this is also known as hard coal, that was formed from bituminous coal under increased pressures in rock strata during the creation of mountain ranges. Say rocks after rocks, rocks after rocks. There are a number of layers of rocks which have hardened this coal. There is increase in pressure due to the layers of the rocks formed, and also the high temperature that has led to the formation of anthracite. It is very hard and shiny. This type of coal is most compact and therefore has the highest energy content of all the 4 levels of coal. This anthracite has around 92 to 98% of carbon. In this anthracite, there is 92 to 98% of carbon is present. It is used for space heating and generating electricity. Right? So it is mainly used for heating and generating electricity. See, this is the formation of coal. I have told you about this. See how coke is made. It is a hard, dry fuel produced by heating bituminous coal to a very high temperature in the absence of air. Right? Coke has a high carbon content and is used as fuel and in steel manufacture. See, coal in any form is used as a fuel only. Coal tar, it is a thick, black, opaque fluid obtained as a byproduct of the process of manufacturing coke. Say when coke is manufactured, bituminous coal is taken, whose carbon content is around 60 to 80%, and it is heated to very high temperature in the absence of air. At that time, a byproduct is obtained, that is coal tar. This coal tar is used in anti-dandruff shampoos, ointments, soaps, perfumes. In small amounts, of course. Coal gas, it is a gaseous fuel obtained as a byproduct of the process of manufacturing coke. See, well, when coke is manufactured, these are 2 byproducts. Before the development of natural gas supplies, it was used as a domestic and lightening fuel. This coal gas was used. Right? So this is all about the non-renewable natural resource coal, which should be used with caution. Okay? And it will be exhausted one day. So this is all about this session, students. I'll be concluding this session now. And in the next session, we'll be discussing about petroleum, about the formation of petroleum and also the refining of petroleum. I hope you have enjoyed this session, students. Thank you for listening patiently. And now just go through your text. Don't just listen and say, okay, I have understood and now I not read. Reading is equally important. So after listening this session, just go through the text so that all the concepts are clear to you. Thank you for listening and do have a nice time ahead.